Today, I want to talk about some of the chemistry that goes into something that I've been doing for over half a decade, making marijuana oil. Specifically, I want to talk about the process called decarboxylation that is a necessary step when it comes to releasing some of the potent effects of cannabis. I would like to share with you my coca cannabis oil recipe and also fill you in with some of the scientific chemistry facts of marijuana along the way. The first thing you will need to do is procure some legal marijuana. This can be bought at a dispensary, harvested from your own plant, or purchased from a friendly guy named Randall down in Old Town Chinatown. For our purposes, though, we're just going to harvest it right from our backyard. So here we have the cannabis plant. You reach in here, you can find a good pot to harvest. Cannabis. Ugh. Try again. Perfect. Once you have procured your cannabis, not cannabis, you can start processing it for the oil by removing some of the stems. The main active components in cannabis are THC, which is tetrahydrocannabinol, CBD, cannabidiol, and CBG, cannabigerol. Each of these components have a precursor acid molecule that requires the additional step of decarboxylation in order to unlock some of the psychoactive and medicinal effects in our bodies. The main components that we will talk about today are THC and its precursor, THCA. Now that we've destemmed all the marijuana for our cooking, it's time to measure the ingredients. For the oil that I make, I like to use 1 ounce of cannabis for every 1 pound of coconut oil or oil of your choosing, and add 1 cup of water per ounce or pound. After removing the stems, most people like to grind their marijuana, exposing the most surface area for decarboxylation. The THCA in fresh marijuana doesn't have the psychoactive effects that those who have used cannabis are used to. But it has many medical uses that are currently being researched, like epilepsy and arthritis treatment, as well as exhibiting anti-carcinogenic properties. As more states legalize the use of recreational marijuana and the federal government becomes more lax on its restrictions, we will more than likely see a surge of new research on the medical benefits of the cannabinoids present in marijuana. Now that we've ground our marijuana and processed it, it's time to actually go through with the step of decarboxylation. Personally, I decarboxylate my marijuana at 220 degrees Fahrenheit for 1 hour. Make sure to set a timer, because if you leave it in too long, it could burn. As we know from our 3 to 4 terms of college-level chemistry, a carboxyl group, also known as carboxylic acid, comes in the form of RCOOH. In freshly harvested, uncured cannabis, the main psychoactive ingredient, THC, comes in the form of THCA, which is tetrahydrocannabinol acid, which is essentially a THC molecule with the carboxyl group attached. In order to get THCA to turn into the psychoactive THC, the THC molecule must undergo a process called decarboxylation. Essentially, decarboxylation is a chemical process that removes the carboxyl group from the molecule. This reaction can be activated by an activating factor or can be catalyzed by the presence of decarboxylase. In the case of marijuana, decarboxylation happens with the addition of heat for quick decarboxylation, or over time as the cannabis naturally dries and cures. This is why smoking marijuana or cooking it into an oil can unlock the psychoactive effects of THC and cause what we consider to be a high. But what actually happens when a marijuana bud is heated or dried? Essentially, with the addition of heat, a first-order kinetic reaction happens that breaks off the carboxyl group from the greater molecule. The carboxyl group leaves its hydrogen behind and forms a more stable molecule, a carbon with 2 oxygen double bonded to it, also known as CO2. The removal of this carboxyl group alters our THCA molecule into its more infamous form, THC. Additionally, most of the other major cannabinoids in the marijuana flower contain carboxyl groups. So decarboxylation not only affects THC, but it will also help activate some of the medicinal properties of CBDs, CBGs, and CBNs. One thing to consider is that the acidic forms of these cannabinoids contain medical properties that are altered or lost through the decarboxylation process. So depending on your desired effects, decarboxylation may not be necessary. Now that our cannabis is all decarboxylized, we can add it to our oil. Although decarboxylation is not required when making a marijuana-based oil, it does make a better product. When making an infused marijuana lipid, I prefer to use coconut oil. Coconut oil can be used in a 1-to-1 ratio with butter for most baking recipes, and it has a large percentage of saturated fats, which make it an ideal carrier for cannabinoids during infusion. We will set the burner to low and cook it for 8 hours, stirring occasionally. So, why is decarboxylation important? Well, THC, as discussed before, has psychoactive effects that are commonly used both medically and recreationally. When the carboxyl group is removed, the THC can bond to the cannabinoid receptors in the central nervous system, causing the effects that marijuana is generally associated with, like euphoria,
altered sense of time,
relaxation, and increased appetite, scientifically known as the munchies. After you've cooked your marijuana oil for 8 hours, strain out all the solids and put all of the liquids in a nice safe container for refrigeration. Refrigerate for about 12 hours or overnight, and you should get something that looks about like this. Take a simple knife, cut around the edges, pour out the liquid, that's the old water, and you should have a nice disc of cannabis oil. Reheat this and put it in jars to refrigerate, and boom, there you have it. A beautiful cannabis oil that you can share with friends and family. I've been making edible oil with marijuana for about 6 years, and the oil I make got exponentially better with the added step of decarboxylation. Oil is the perfect carrier for THC because tetrahydrocannabinol is fat soluble. This makes it ideal to add to any baked goods. You could also use it to sear a steak or saute some garlic for that special red sauce at the family spaghetti cook-off that magically calms down crazy old Aunt Agnes.
What'd you say to me, bud?
Well folks, that's all I got. Thanks for watching, have a nice night, and remember to stay hydrated. Oh, and full disclosure, she's not really my aunt.